In this video, we'll explore quadratic functions. Now, we often look at quadratic functions in two different forms, the general form and the vertex form. While the general form can help us find the zeros of a function, the vertex form is very helpful in understanding how to graph the actual function. So how do they relate? Well, if we start with the general form, we can work on trying to complete the square, and it will actually come out creating the vertex form. So let's shift the c to the left-hand side. If we pull an a out of both of the x's, we end up with x squared plus b over ax. And now we can actually try to complete this square by adding the b over 2a quantity squared. But remember, when we do it to the left-hand side, we need to also multiply it by a, since this whole expression is being multiplied by a. Simplify it down. And if I create a common denominator here of 4a, I'm going to get 4ac over 4a, which means this can be combined into a single term and added to the other side. Now, why would that be useful? Well, by knowing this, and this is in vertex form, we now have our h and our k value and how they could relate back to general form anytime we have the general form of the function. Saves us a lot of time in trying to find things like the maximum or minimum of the quadratic function. So we know that if we take those coefficients, we can find that max and min very quickly. So let's look at an example. In the United States, the birth rate of unmarried women per 1,000 unmarried women can be modeled by this given function. So if we want to find out, well, what's the highest age, or what age has the highest birth rate, and what is that birth rate, we could use this function and find the maximum. Well, if we think about the maximum, it occurs at the vertex, and what we just found is the expression on how we could find the vertex, using negative b over 2a, and then for the y value, 4ac minus b squared all over 4a. If we plug in our a, our b, and our c from our function, a, b, and c, we can then simplify in that we get 26 and 35 hundredths and 67 and 33 hundredths. Well, what does that mean in context of this problem? It means that 26-year-olds have the highest birth rate, and they're having about 67 births per 1,000 unmarried women. Now, if you forgot this form, you could also just graph the function if you have a graphing calculator or some other program that will allow you to graph. And then from there, find the maximum of that function, and you'll get that again the same solution. Now, one of the most iconic parabolas that we have in the US is the Gateway Arch in St. Louis, and it can actually be graphed on the function as well. If we put it on the coordinate plane where the left base would be at the origin, we'd end up with this function. Say you want to know, well, what's the maximum height and the width of the Gateway Arch? We know that the maximum height is going to occur at the vertex, and this happens to be in vertex form, which makes that very simple, because we have our vertex of 315, 630, so we know it's 630 feet tall. Now, to find the width, we need to find our two zeros. We know one is at the origin, and we need to find the other one. So we could graph it, and we would see that it comes at 630, 0. And we think about, well, what's the horizontal distance here? From 0 to 630 is 630 feet wide. So the Gateway Arch is actually 630 feet wide and 630 feet tall, which is kind of a neat feature of this arch. Now, if we didn't have something to graph, how could we go about doing this problem? One way would be to convert back into standard form. So if we start with our vertex form, we can expand the x minus 315 quantity squared to get to the standard form, or our general form. Now, I changed this fraction from 1 over 175.5 to 2 over 315 to remove the decimal, which simplifies my problem as I'm trying to redistribute the 215 through the problem. So when I do that, and I simplify all my expression, I end up with negative 2 over 315 x squared plus 4x. From here, I could either factor or use the quadratic formula. Factoring is the easiest because I have no constant at the end. So I could factor out an x from both terms, and then I can set each of those equal to 0. And when I do that, I get that x equals 0 and x equals 630. And the distance between those two values is 630 feet. So again, back to that solution we just found. Now say you weren't sure if you could just factor, you could also use the quadratic formula. So remember, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And a, b, and c are coming from that general form. So we had our general form. In this case, our c value is 0. That's an important thing to recognize. So that what I'm looking at, when I plug in all my parts, I've got a value of negative 2 over 315, b equals 4, and c equals 0. Well, that makes this inner part that's being subtracted become 0, so 4 squared, and the square root of that is just 16. And the square root of 16 is 4. So negative 4 plus 4 is 0. And then if I did negative 4 minus 4, I'm going to get negative 8. And then we'll multiply by my reciprocal. So I've got negative 315 over 4. And that comes out as 630. So again, I'm back to the fact that I'm 630 feet wide from 0 to 630.